Hi, welcome. We're starting a new unit on graphing quadratic equations. This first lesson is 5.1 on standard form. What is the information that we can get from a quadratic equation in standard form? As a reminder, uh, f of x equals ax squared plus bx plus c is standard form. Sometimes we see 0, but that's just when this is equal to um, 0 when the y. So one thing to keep in mind here is that y equals f of x. And so instead of f of x, if we wanted to, we could just write y there. The y-intercept is the c coordinate, 0, comma c. It's the last thing. So if we look down at this example down here, f of x equals x squared minus 8x plus 7. So the y-intercept is 0, comma 7. It's from that 7 is the constant term in the quadratic equation. If we look at what it looks like over here, that point right there is the point 0 in x, 7 in y, and that's the y-intercept, the point 0, comma 7. All right, let's look at the next one. The vertex. The vertex is x is equal to negative b divided by 2a, and that's from using the b and the a there. So that will give you the x coordinate, and then you substitute that x coordinate, whatever you found, substitute the x coordinate into your function to find the corresponding y value of the vertex. And what is the vertex? Let's look at this. So our value of a is the number before the x squared, which is 1. We've got negative 8, b equals negative 8, and the vertex is negative b, x equals negative b over 2a. And so since 8 is negative 8, we have the negative negative 8, which is positive 8, divided by 2a, and a is 1. So we've got 8 divided by 2, and the x coordinate is 4. We then take 4 and we put it into the equation. Remember the equation, y is equal to x squared minus 8x plus 7. So if we said, okay, x is here and x is here, and our x coordinate of the vertex is 4, we put 4 in for x here and 4 in for x there. We evaluate that, we would get that y equals negative 9. So we're at 4, negative 9. The vertex is a point 4, comma, negative 9. Let's look at the graph. 4, negative 9, and we go down here. Here's 4, and here's negative 9, and so that point 4, negative 9 is the vertex. 4, comma, negative 9. And let's see what's next here. The axis of symmetry, the line x equals negative b over 2a. The axis of symmetry, we already calculated x equals negative b over 2a, and that is x equals 4. And so x equals 4 is a vertical line that goes through 4, runs up and down through the parabola, and every point, it marks points that are equidistant all along the way. Like this point right here, for example, is equidistant over here. Maybe easier to see if we look at this point up here you can see is 1, 2, 3, 4 units from the axis of symmetry, and over on the other side we have 4 units from the axis of symmetry on the other side. So the axis of symmetry can help us to graph points, because if once you know what the axis of symmetry is, you can just count to one side of the line or the other. All right, let's look. What's next? So axis of symmetry is x equals that line that we get from the vertex in the problem before. Direction of opening. If A is positive, it opens up. And it opens down if A is negative. So if we go down here, A is 1, A is positive, that means this opens up. And indeed, it opens up. If you're, wondering, just think, okay, if it's positive, then it opens up. All right. Moving right along, and down if A is negative, and we didn't see that example in this yet, but we will in other examples. Maximum value, the y value of the vertex when the parabola opens down, or the y value of the vertex when the parabola opens up, would be a minimum. Maximum if it opens down, minimum if it opens up. Since it opens up, remember that minimum means the smallest. And so the smallest value here is y equals -9. It's the smallest. It doesn't go any lower than that. And so that's the minimum. When we say that it's a minimum, the minimum point is 4, -9. The minimum value would be just -9, the y value. The minimum value is y equals -9. All right. The domain. The domain is all of this, the set of all x, all the x values that you can have for a given function or equation. In this case, the domain is all x values because it continues to go up and out to the left, and it continues to go up and out to the right, and it includes all of the points in between. And so we write that in interval notation in the following way. It's got parentheses, negative infinity to positive infinity. It includes everything in between. The range, however, it uses a bracket because it can be equal. When you use a parenthesis when it can be equal, you can't be equal to negative infinity or positive infinity, but you can be equal to -9. And in fact, it is equal to -9 when x equals 4. So the range values, I'm getting ahead of myself. The range values are all the y values that you can have in a given function or equation. So if the parabola opens up, the range is k to positive infinity. If the parabola opens down, the range is -infinity to k. You always have the smallest value first. And so in this case, the smallest value is -9. And we did use a bracket to show that it can be equal to -9. And then it goes all the way up to positive infinity because there's no top limit here. All right, I'll see you in the next video.